cosine or sine, and then the dot product and the magnitude. So we need to visualize this. The plane is going like this. There's some line going through it. Now the problem is we don't have a vector along this plane. Well, but we can get the normal to this plane is very easily read. We can get the normal to the plane. What's the normal, Sarah? Normal? To this plane, yeah?
Would you like me to say
I would, yeah.
113?
It would help if that was written correctly.
Yeah, that's not quite right, sorry.
Oh yeah, oops. 113, oops. 113, yeah. Not 133, okay, so yeah, the normal is created from this. So we got this normal vector, and what's the direction vector of this one? From this -1, 1, and p. Okay, when we go about finding the angle between these two, that's this angle, isn't it? So we can either think about that as cosine 30 or sine 60. It'll be the same, because the acute angle is 60. That's this angle is 60, which means this angle is 30. So you could use cosine 30. So we have a formula for this. Cosine 30 is equal to n dot d over n times d, the magnitudes of the two. That's in a formula booklet, I think, or something similar to that. It might be rearranged slightly differently. This might be over here. So cosine 30 we need to know is root 3 over 2. The dot product is multiply the x's, the y's. So 1 times -1 plus 1 times 1 plus 3 times p. And then we're dividing by the magnitudes of them both. So that's 1 squared, 1 squared, 3 squared, which is root 11. And we get 1 squared, 1 squared, that's 2, plus p squared. Okay. All right, now I need to work this out. Okay, I'll get rid of my diagram. I need to work this out as best I can. I have root 3 over 2 is equal to, in my numerator here, -1 plus 1, they disappear. I think I'm just left with 3p. Combine these together, I get root 22 plus 11p squared by multiplying the 11 into both.
And you cross multiply?
Yeah, cross multiplying is something you can do. So multiply both sides by this, we get root 66 plus 33p squared, since the 3 multiplies in, and we get a 6p here. Solving this, square both sides, get rid of the square root. 66 plus 33p squared is equal to 36p squared, so I square both sides.
Oh, you put the in.
Subtract this over here. There's only 3 of them left when there was 36. Divide by 3. P squared is 22, so p is square root plus or minus square root 22. So that's why it says values, possible values of y, of p. Okay, sir? Yep. All right, let's look at question 5, which was the long question. Very long question.
Here's question 4.
Just a bit interesting.
Okay, let's get up on screen. Oh, lots going on. So there's 3 vectors to start off with. So we're given these 3 vectors, OA, OB, OC. And they're given in IJK form. Let's take them down correctly. They're all pretty, well, using the same coefficients. Same numbers. Minus k. Okay, so there's the 3 starting points. So the first thing I want to do is find the vector equation of A of AB. Oh, not the vector. That's not how you spell equation. Okay, so the line AB, we want to find the vector equation of that.
Is it negative OA plus OB?
Yeah, so we need to fill in a position vector here plus what variable did I use? I used t, but you use lambda or something maybe. It's probably more accurate. You use t? I'll go with t as well.
I didn't use anything.
Oh, I didn't do it? Oh my goodness. All right, so a position on the vector equation AB. What's a position? Oh, blank. False.
Well, from O to A is 1, 2, and 3.
Yep.
So it will be 1, 2, 3.
1, 2, 3, yeah. If O to A is 1, 2, and 3, where is A? It must be at 1, 2, 3.
Yeah.
Very good. Okay, so we do need to know what the vector between from A to B is. How do we get from A to B?
Negative OA plus OB.
Yep. So, anyone give me that?
Minus 1 plus 3, 2, minus 2, minus 4, 2 minus 4.
So if you want to write it differently, A is 1, 2, 3, isn't it? OA and OB is 3 minus 2, 1. So how do I get from A to B?
Minus OA plus AB.
B minus
Yeah, so you can subtract here if you want.
Subtract.
Oh, 3 take, subtract this way, yeah?
yeah.
2 minus 4.
2,
So
2 minus 4, so how do I get from here to here, here to here? Minus 2, yeah. So I, up 2, down 4, or whatever direction you're talking about, and down 2. Okay, so that's the vector equation, not too bad. Part B then, or part 2. Determine whether lines AB and OC are something. Are parallel, skew, or intersecting? Oh, awesome.
And they're definitely not parallel.
I can't spell parallel today. Skew,
I can never spell parallel.
intersect. Yeah, it's 2 L's.
They're definitely not parallel.
Okay. You're very confident they're not parallel. How are you so confident?
The ratios of the.
Okay, so let's look at this direction vector. AB has this direction 2 minus 4 minus 2. OC is 3, 2, 1. So OC is 3 or 2 minus 1. There's no scalar multiple there, so they're not parallel. So we can maybe suggest that 2 minus 4, 2 does not equal a scalar multiple of k, so not parallel. We can rule that out. Very good. So either skew or intersect.
You'd have to let them equal each other or something?
Well, I suppose we'd have to presume that they do intersect.
Yeah.
And if they, what will I get as an answer if they are askew? If I presume they are intersect, I presume there's answers for where they cross over.
If they're skewed, there wouldn't be an answer.
It wouldn't be.
Yeah, okay, so I have a vector equation for AB. Do I have one for OC to figure out?
3, 2 minus 1.
Okay, so this second one,
0, 0.
yeah, you could do 0, 0, 0 as a position. And I know my, I'll just use R2 or 1. I'll use S here. S is the direction it goes. So it goes 3, 2, minus 1. So a position on it and a direction. Okay, so these are my two lines, this one, this one. I want to see, do they intersect? How do I, if someone told me they did intersect, what would I do?
They would have a point where they.
The X would match the X, the Y would match the Y, and the Z would match the Z. So remember that this is X, Y, Z, and this is X, Y, Z. So this X has to be the same as that X. That Y, at some point, they'll have to have one common place that along whatever parameter it is along the line, eventually they have one spot. So let's let the X bits equal each other. 0, we'll use this one first. 1 plus 2t, so this is the X's, equals 0 plus 3s, so just 3s. The Y coordinates, 2 minus 4t is equal to 2s, and the z coordinates 3 minus 2t, this is z, is equal to minus s. Okay, so I have to do some solving here.
And we gotta rearrange them so.
Yeah, okay, so we got 3 equations to work with here. I'm going to rearrange this one maybe, or I can just try and solve this one. Maybe we pick these 2 and try and solve for it. If I multiply the second one by minus 2, I get minus 6. This is multiplied by minus 2, not minus 3, minus 2. I get minus 6 plus 4t minus 2s. So I'm looking to eliminate the t's here, that's why I did that. And I get minus 4 is equal to
Oh, I just substituted it.
minus 2, sorry, that'd be plus 4s. Oh, so things are looking good. S is minus 1. So we get s to be minus 1. Okay. Let's find the corresponding value of t using this one maybe. So 2 minus 4t is equal to 2s. S is minus 1. 2 minus 4t is equal to 2 times minus 1. So I get, that's minus 2. That becomes plus, I think if 4 is equal to 4t if I rearrange a little bit. So t is 1. Things are looking good. How would I know for sure then that these work? They must also work for the first one. So let's make sure that it does. So at the moment, we're thinking possibly intersecting. There's nothing to say that it doesn't yet. 1 plus 2, t is 1. T is 1 is equal to 3 times minus 1. That's incorrect. 3 does not equal negative 3. Therefore, they are skew.
Is that the correct answer?
Yes, they are skew.
If you do it with what's the x and the y one, or the first 2 ones, you end up getting 3 equals 0. It's funny.
Yeah, I did it with 2 other ones, and I got a quarter is equal to 2 or 1 3/4. A quarter is equal to 1 3/4. Doing 2 different ones. So you just get a bunch of different answers. There's no place where they're the same, which is awesome. What was that? 4 or 5 marks? 6 marks. That's not too bad for 6 marks.
Yeah.
I suppose knowing what to do is, so we have to set up this equation, make sure the x is equal, and so on. Okay, let's look at part C, or I'm calling them 1, 2, 3, so let's look at part 3. Find the Cartesian equation of the plane. So we want the plane, which is marked 2. 1. Read that wrong. Plane 1, which is the plane that passes through point A and perpendicular to one of these ones, OC. Okay. Let me get. Yeah, so if it's the plane is perpendicular to OC, that is a good. So the plane, so OC goes this way, and the plane goes this way. That means OC is the normal to the plane. Is a normal to the plane. Make sense? This is okay. So therefore, OC is normal to the plane, which is very useful. Because I'm going to do the normal times or is equal to this one.
It's just asking you for what you
To create an equation of a plane. This or is XYZ.
Wait,
Yeah.
is that the Cartesian equation?
It will give the Cartesian equation, yes. Because it'll have XYZ in it.
What's the one that's like ax plus by plus
That's Cartesian.
that's Cartesian?
Yeah. They all lead to the Cartesian. There's just different ways of getting there. Normal was OC. So the normal OC is here, 3, 2, minus 1. 3, 2, minus 1. Very good. On this side, we have 3, 2, minus 1. What was D again? D is the position on the line, isn't it? On the plane. So that's why they said through A.
Through
A is what we.
so 1, 2,
I probably should have put P there, not D. That's why I said through A. So that's giving us a point on the plane as well. So using this formula, we can get the vector equation. The point A, I've forgotten where it is. Oh, here. 1, 2, 3. 1, 2, 3. Okay. So using this, we get 3x plus 2y minus z. 3 times x, 2y, z, dot product, is equal to 3 times 1 plus 2 times 2 plus minus 1 times 3, which gives something. Have you worked it out? 3
4
gives 4.
The threes
Yes, the 3's conveniently cancel. That's a z is equal to 4, yeah. So 3, and that's minus 3, and this is 4 in the middle. Make sure. So I got earlier it is. Okay, so that's part
Wait, sorry.
C. Racking up, so that's 12 marks, so that should have taken you about 12 minutes. Part 4 then, next part, is asking about show that the line AB lies on the plane. Show line AB lies on plane.
Well,
This one we just
the
created.
start is the fact that they both have the point A. So we know that that can be like the starting point for their equations, right?
Okay, so if they both have the point A, does that mean that they both, that is parallel?
Well, no, then we need to look at the direction.
Well, you just need to look at the point B.
You'd have, no, you'd have to look at the direction vector.
Or you can look at the point B, yeah.
Or you look at the point B, because if point A is already on it and point B is on it, then
Good point.
you know,
Yeah, if point A and B are both on it, so how do I show that point B is on it? B is over here, 3 minus 2, 1.
substitute values.
Yes, we have this vector equation for all 3 positions. So if 3, 2 minus 1 equals 4, we're sweet.
So we find
It does equal 4, in fact.
oh,
It does.
we can't just put them into the x plus 2y minus z equals 4.
Yeah, when you're doing the question, you wouldn't need to do the A one again, would you?
We got to do the direction, not the position. Position is not going to give it.
Does the position give a 4?
No,
It doesn't. It's
No.
3
it's
minus
got to be the
4
vector.
minus 1.
You sub in the vector.
Minus 4 minus 1.
9 minus 4 minus. Where are you getting that from?
Because B's at 3 negative.
Oh, I've subbed in the wrong point.
Yeah, it just works.
You don't need to find the vector. A to B would be also be on it, but we don't need to because we have B.
If both points A and B are on it, then it
Yeah.
kind of.
I don't know why I was looking at OC. Anyway, what is B? B is 3,
Negative 2, 1.
3, negative 2, 1. So that's our point B from over here.
Plus 2y minus z.
So 3 times 3 plus 2 times minus 2 minus 1 is equal to 4. If that works out, that's 9 minus 4 minus 1 is equal to 4, and 4 is equal to 4. Yes. I forget. This is just. Yes is not the right way to say it. Show that it lies. Oh, therefore,
So
A and B lie on the plane. Therefore, the equation. Because it's not going to deviate.
It's a straight line. It should stay on this.
Yeah, it's going to stay on that path. So if A and B, connecting them, are on the plane. So to find see if a point is on the plane, you just sub it in, and it should left hand side should equal right hand side. Okay. Moving along. Part E. Verify. So we got this plane 2 is the plane with OA and C.
We don't even need to.
And well, we just set it up anyway. Plane 3 is for later on O, B, and C. And question part E says verify that
We don't even need to.
4i minus 5j plus 3k
Take the. Because we know OC
is perpendicular
we know OC
to
so as long as
plane
this is
2.
because it says so. Because OC is perpendicular to. Oh, that's a different. My bad.
Okay, so we do need to do some stuff here. Verify that this is perpendicular to the plane 2. Have we created plane 2? No, we have not. Oh no. Right, that means we have to create plane 2. How do we create an equation of a plane?
A to O, O to C.
A to O to C would, if you dot product it, no, that's not going to work. But we know that if we cross product, we create a normal vector, don't we? Like that, yes. So A to O, so we need to cross O to A and O to C, and that will give us the normal. Because that creates a... So O to A is 1, 2, 3. O to C is 3, 2, minus 1. And we got to cross product that into creating a normal vector. So we can form the equation of the plane. Okay. So you may have your cross out methods, or you just go to the formula booklet here. I think you get minus 2, minus 6 for the x. So do that one. Then the middle one, cross out the middle 2. Should get minus 1, minus 9, I think. No. I've done it the wrong way. You got to go this way first. Yes. Yeah. 9 plus 1. That's why you use the formula. Yeah, use the formula. Don't. You go this way first, and then cross these out. You should get 2 minus 6. Yes, 2 minus 6. So use your formula booklet. Don't do what I did there, because you make a mistake like I did. Negative 8, 10, negative 4. That's the normal vector at that particular spot.
Then you just
divide it by 2 and show that it's the same.
Yes. So we're verifying that this is perpendicular. So this is a vector perpendicular to the plane. They want to verify that this is perpendicular. No, that was a 2, is it? Have I taken it down wrong? Yes, I have. That's a 2k. 2k. So this is a scalar multiple of this when k is negative 2, I think. K is negative 2, yes. Therefore, they are parallel, which means it's perpendicular, because this is perpendicular. Okay, so this normal is perpendicular, so this is perpendicular too. Those two lines are parallel. Okay, what's that word? 3 marks? 1 mark question. Find vector.
You just do the same thing. It's just a cross product.
Yeah, so find the vector perpendicular to plane 3. Now plane 3 is OBC, so cross product again. Yeah, it's pretty strange one. 3 must use in the next part, do we?
Yes.
B 3, 2, minus 1. So we do that same cross product thing. I'll just give you the answer.
Okay.
0, 6, 12. 0, 6, 12, which you can. That's 1. That's 1. That's or some k multiple of 0, 1, 2. Will be it. I see you're full of energy. No. You could just say that one. Okay. And so that's what it just said. Find a vector perpendicular, not all the vectors.
Yeah, okay.
Oh yeah, I guess that's true.
Find the acute angle between plane 2 and 3. Very good. Actually, this question is pretty straightforward. Maybe. Find the acute angle between the two planes. So you think this is plane 1, plane 2. What you end up getting, of course, is because it's difficult to find a direction vector.
Is it supplementary?
You create this thing, don't you? You create the 2 and you get this angle. That angle has a really...
Then 180 minus that
Yeah,
angle.
180 minus the angle that you get from the
Okay, so how do we get, first of all, we need the two normals. Two normals,
0, 6, 12 is one of them.
0, 6, 12, yes, we can use 0, 6, 12. What we're doing with those two normals, we are dot producting the two normals, so 0, 6, 12. So we're looking at cosine theta.
So which one are the two normals?
The sine y.
This is the plane 1, or plane 2 and 3, and this is a normal,
Oh, those two.
normal 2, yeah. So they meet somewhere there. So
4 minus 5, 2, whatever it is.
yes, so that's this one, this is the other one. You can use 4 minus 5, 2, or
I like smaller numbers.
I'm going to use negative 8, 10, just because it was the one that was created.
Fair enough.
You'll get the same answer, because they're scalar multiples. So I'm using the normal, the other normal I created. That's these two, dot product, magnitudes, 0 squared plus 6 squared plus 12 squared times minus 8 squared. And this is where you pull out the calculator. Plus minus 4 squared. You dot product this, of course, you'd need to do that. So that's going to be 0 plus 60 minus 48 all over whatever this is, and this is cosine inverse, and we get an angle. What's the angle going to be? 86 degrees.
Well, the ending angle is going to be 86 from that. If we're doing that, you should get 94, and then you would subtract 180, right? Or 180 subtract 94. Or does that method just get you straight to 86?
That method should get you straight to 86. That's going to be the same angle as over here.
What? And how did that? Well, I got 86.
You did. Did you use cosine inverse?
Yeah, and then I got 94, and then I did 180 minus 94.
Well, you always know it's going to be the acute angle. So you either you've either found the angle on this side or this side. So you're always going to go with the acute one.
Yeah, I'm just confused about how you would exactly.
It's because my diagram doesn't look great.
Well, that's not exactly because you use the formula there.
Hmm?
I guess it doesn't really matter. But yeah.
So so this will be the acute angle, it's the same. Go back and watch the video where we did that one. The same angle. And if it's more than 90 degrees, you've found the other one. Because you would have used negative. That answer up here would be negative. Did you get a negative answer up here?
Yeah.
Okay, well, yeah.
Oh, then okay. Then
So you found, yeah, so you
because
then...
I use 0, 1, 2, and what's it?
Yes.
Be 4, negative 5, and 2.
Okay, yeah, so that will
Yeah,
create,
that would do it.
that will create a negative up there, which is, then you recognize that it should be the acute angle, yeah.
Yeah, because you use the absolute.
Okay, so it depends on if it's positive or negative.
Yeah,
You can also just use the absolute value of
Yeah.
the dot product because that
Yeah.
always gives you the angle. Yeah.
Okay.
Yeah, so you got, oh no, it'll be scaled, but yeah.
But regardless, if positive, then it's fine.
Yeah, you know, well, yeah, it's going to be positive, it's going to be less than
You
90
just get the
degrees.
acute angle.
Yeah, you're
It's
just
not
going to
that-
get, yes. Okay,
It's not that complicated.
all right.